Whenever two materials are rubbed together, electrons may be transferred from one material to the other, causing a build-up of electrical potential in the materials, known as static electricity. This applies to the airframe of an aircraft as it rubs against the atmosphere that is flying through. In this lesson, we will look at how the build-up of static electricity on an airframe in flight is dealt with. And we will discuss how the build-up of static electricity in refueling equipment is prevented. We will also look at how components are protected from electromagnetic interference produced by the operation of other components. The airframe of an aircraft in flight collects electrons from the atmosphere and gains a static electrical charge as it flies through the air. If different parts of the airframe have different levels of static electrical charge, then there is a possibility of a spark being generated between them, leading to the danger of a fire or even an explosion. Any static electrical sparks will also cause interference in the form of static noise or crackling in the aircraft's radio equipment. In order to prevent these problems, all pieces of the metal structure of the aircraft and all components in the aircraft are linked by flexible wire strips. This process is called bonding, and it provides an easy path for electrons to move from one part of the airframe to another, thus maintaining all parts at the same potential. Bonding also acts to maintain the earth return in a unipole electrical system, which is a system using only one wire, with the return current passing through the metal airframe. The unipole system is fully described in another lesson. The static charges that build up on an aircraft during flight tend to accumulate near sharp edges, like the trailing edges of wings and tail surfaces. A static discharge system, consisting of components known as static dischargers or static wicks, is fitted to reduce the build-up of static electricity on the airframe. Static wicks are fitted to the trailing edge of the aircraft control surfaces and the tips of the wings and the tail. The purpose of the static wicks is to provide a conductive path for the excess electrons to flow or leak from the aircraft back into the atmosphere. This transfer of electrons reduces the charge on the aircraft's skin and structure, thus reducing the possibility of interference in the aircraft's radio equipment. Static wicks are fabricated with a wick of wire or a conductive element on one end, which provides a continuous low-resistance discharge path between the aircraft and the air. Static discharge wicks also provide another important safety benefit. In the event of a lightning strike, an aeroplane is designed to conduct the excess electricity through its skin and structure to the wicks, to be safely discharged back into the atmosphere. Though this massive electrical charge often burns or melts the wicks, these devices are simple and easy to replace. Remember though, static wicks do not prevent lightning strikes. They simply help to mitigate the effects. To ensure that no static electrical charge remains on the aircraft after landing, the airframe is brought into electrical contact with the ground as the aircraft touches down. This is achieved by using tyres which contain a high proportion of carbon in the rubber. The tyre and wheel are in contact with the airframe via the wheel bearing, and any static charge is dissipated to Earth on touchdown. During refueling, and particularly during pressure refueling, the high fuel flow rates can cause a build-up of static electricity in the refueling equipment. This can cause a difference in electrical potential between the refueling equipment and the airframe, leading to the possibility of a spark being generated with catastrophic consequences. Before fueling commences, the aircraft must be bonded to the fueling equipment, using dedicated wires and clips. This ensures that there is no electrical potential difference between the components, which could lead to sparks. Static electrical charges, radiating from the sparks produced by the constant switching of certain electrical equipment, create interference in radio circuits. This interference is overcome by fitting interference suppressors, usually capacitors, in the cables connected to the source of interference, and by total enclosure of the cables in a continuous metal sheath. This is known as screening. Screening is required for ignition systems, DC generators and motors with commutators, slip ring machines operating at over 200 RPM, and also for any electrical equipment making and breaking a circuit at a frequency greater than 10 cycles per second. That is the end of the lesson. The important points to remember are that bonding of the airframe components reduces the possibility of interference in the form of static noise or crackling in the aircraft's radio equipment, and that static dischargers or wicks fitted to the tips of the wings and tail discharge static electricity back to the atmosphere, thus reducing the possibility of static interference in the aircraft's radio equipment.